Today's presentation is on electronics, cable, and wire harnesses. I'm Courtney Stevens, an attorney in Medmarc's Risk Management Department. On behalf of Medmarc and today's presenters, Julia Markhardt, William Brennan, and Paul Hugo, thank you for joining us. Julia Markhardt is an electronics staff engineer with the Performance Research Institute. She has 40 years of experience in the electronics industry, including extensive experience with NASA and U.S. military projects. She is an adjunct professor at Eastern Florida State College, and there she develops the Soldering and Advanced SMT program and helps develop the Space Tech program. William Brennan is the Principal Supply Quality Engineer for Cables and Harnesses with GE Healthcare. William has been working with C&H for 15 years and has been considered the Supplier Quality Subject Matter Expert for GEHC since 2005. He is well versed with the cable and harness industry, standard IPC WHMA A620, and has both cable connector design and assembly experience. He's performed over 25 cable and harness supplier audits for process capability and control and helped guide suppliers who have failed cable and harness audits to passing scores. Although he has not seen it all, he has definitely examined many cable failures over the past 10 years and has personal ownership of a cable and harness defect library, which he uses when training GE Healthcare employees in his Cable and Harness University lessons learned and best practices training classes. Paul Hugo is the Director of Quality for Global Technologies, a worldwide supplier of cable and wire assemblies based in Spring Lake, Michigan. He is a materials engineer, graduate of Rensselaer Polytechnic Institute, where he also completed a master's in materials science. He has achieved certification as a Certified Quality Manager, CQM, and a Certified Quality Engineer, CQE, through the American Society for Quality. Paul helped lead Global Technologies' efforts to achieve Metacred accreditation and participated as a supplier representative on 2 audit criteria development task forces, cable and wire harnesses, and process validation. He is an avid swimmer. He loves early morning summer swims in Lake Michigan, and where he lives in Spring Lake with his wife, Diana. With that, I am pleased to turn things over to Julia, who will begin today's presentation.
Thank you. Today we're going to address the critical manufacturing processes that are used in cable and wire harness manufacturing. I'll give you a few examples of some product failures. I'm also going to show you the critical process elements of cable and wire harness manufacturing. I will talk about some of the FDA findings and how Metacred can help. I'll also give you some insight as to the top non-conformances that we found in the past year while conducting Metacred accreditation audits and some typical initial root cause responses that we've seen. Then I'll explain what the medical industry is doing to improve cable and wire harness quality and supply chain oversight. And later in the presentation, we'll be talking about the critical manufacturing processes and the best practices for ensuring quality, consistency, safety, and reliability. And the picture on the screen, actually I'm standing in the background, is one that was taken during Global's audit, their initial audit, and they are the first supplier to have achieved this accreditation. Let's first take a look at 2 products that were recalled by the FDA. You can see the first one there is an anesthesia machine and monitor, and the reason for the recall, it was an unanticipated shutdown, a specific lot of machines. The control board wire harnessing had a defect, and it says which can cause the machine to unexpectedly shut down, terminating ventilation, anesthetic delivery, and potentially patient monitoring. So you can see these, these pieces of equipment are so very, very important. So we have to ask ourselves, what went wrong? What happened to the process validation? And we'll be talking a little bit more about that. Did someone deviate from the process? Was it a counterfeit or substandard component? And during the Metacred audit, verification of manufacturing processes would ensure product realization. And the second one there, we'll talk about in just a little bit, but Paul, I believe that you had something to add here.
Yeah, I think it's important to note the structure of these audits. They're set up to look at a supplier's system from acceptance of specifications, including prints, how you convert that to your shop floor information, and then how you ultimately get it to the final product. And the audit focuses on that process, not necessarily the quality system processes.
And the second example there, we have an ultrasonic cleaner. We find a fire hazard. Apparently the unit smoked and sparked. They were subject to water damage at the lid switch cable wiring harness, and most likely the component was not sealed properly. The non-conformances that we will be discussing today could lead to product failures such as these. On this next slide, you see the scope of our audit checklist. It's called the AC 8121, and it includes all of the critical process elements. The audit includes an in-depth look into each of these areas. So you can see we have process validation, also medical record keeping, ESD, electrostatic discharge, tools and equipment, calibration, preventative maintenance, facility environmental management, purchasing and authentic component assurance, process control, personnel qualification, and visual acuity. Also, magnification and lighting, receipt, inspection, and control of incoming materials, rework, product cleaning, wire preparation and stripping, solderability, gold removal, wire tinning, soldering, and crimping. And unlike quality audits, the MedAccred audit takes an in-depth look at the actual manufacturing processes. The auditors are on the shop floor looking very closely for compliance to work instructions and technical standards, process parameters, soldering techniques, shelf life, and pot life, etc. We're also looking at insulation displacement connection, ultrasonic welding, connectorization, molding and potting, cable assemblies and wire measurement, marking and labeling, coaxial and biaxial wire, wire bundling and securing, electrical shielding, protective coverings, finished assembly, testing, and storage and handling of packaging of finished products. And Paul, you had something to add.
Yeah, so this is a 4-day audit, and the auditor is going to spend half his time on the shop floor. So figure 16 hours plus on the shop floor. Typically, in our plant, they talked about half our employees asking what they're doing, finding the correct instructions. Are they following the instructions as they're written? Most importantly, do they understand the acceptance criteria for their value add? And because these guys are SMEs, they're subject matter experts, if the operator doesn't understand an instruction or a requirement, they're going to sniff it out, and that's going to be a finding. If it happens multiple times in an audit, you can expect a major. If it's a one person, it might be overlooked. 2 people might be a minor. So you have to think about that as unlike a quality system audit, it's truly focused on product realization. Thanks, Julia.
You're welcome. Here's a partial list of the standards that we use for cable and wire harness manufacturing. The IPC standards are the appropriate standards for us to use. We use the IPC WAMA A620 requirements and acceptance for cable and wire harness assemblies. Also, if you're doing any soldering, we use the J Standard 001 requirements for soldered electrical and electronic assemblies. And also, from time to time, you have ESD sensitive components. So we use the ANSI ESD S20.20 protection for electrical and electronic part assemblies and equipment. And while the audits are process audits and not quality audits, we do check to make sure that every company audited has a valid quality system certification, such as your ISO 13485 or your ISO 9001. And our audit criteria also includes the FDA's requirement for medical record keeping, both the 21 CFR Part 820.181 device master record and also the 184 device history record. And also process validation is an important part of all MedAccred audits. And Paul is on that sub-team. So can you talk a little bit about process validation, Paul?
So this is I think one process that is truly unique to the medical industry. All the other industries, aerospace and automotive, and they all have their own little spin on how they manage the process of validating your process, your manufacturing process. So with the medical industry, they've chosen to use the IQ, OQ, PQ approach. And it needs to be understood by supply. My opinion is it needs to be understood by supply, and we need to comply with that because the OEMs and the FDA are working to that standard, so they understand it, they know what to look for, they're comfortable with it. In particular, I'll reiterate, it's the FDA that's driving that. Thanks, Julia.
You're welcome. And how does the Metacred audit ensure quality, consistency, safety, and reliability? Well, here's some examples. We talked about what was in the audit, but here's some examples. With regards to quality, I have soldering there. A poorly made solder joint will devastate your quality. Visual acceptance is not enough, and we always find people that say, "Oh, well, we've inspected it. You know, it passes inspection." But was that solder joint made correctly? So while we require compliance to the IPC WAMA A620, this certification course does not provide hands-on training. Therefore, training to the J Standard 001 for soldering is key. And in addition, on-the-job training on the use of tooling, crimping, connectorization, application of protective coverings, all of that is essential. With regards to gold removal, we use gold because it's a wonderful conductor. The disadvantage of gold finish on a terminal is that gold is porous. It dissolves in eutectic tin lead solder, and it creates embrittled or weaker solder joints. It can then fracture, leading to product failure. So to remedy this, degolding or double tinning is used. If you're looking at a wire soldered in a gold cup, you can't tell if it's been tinned. The operator may not have known that it needed to be tinned if it's not clearly spelled out in the work instruction or if they were not IPC certified. Failure to degold might not be discovered until the product fails in the field. Our auditors make sure these steps are known and followed during the audit. So we stand back and we watch operators work, and we can tell, did you double tin that gold cup? If not, why? What's in the work instruction, etc. Also, process validation is key, and adhering to the process is critical for consistency. The auditors are looking for compliance, and any deviation from the process or use of a process that has not been validated would be a non-conformance. Soldering iron tip temperature is a critical element of process validation. It's knowing the capability of the soldering iron first, then choosing the correct tool and the correct tip size and the correct temperature. Also, the iron's ability to hold the temperature within a specified range. Many suppliers would like to use a wide range of temperatures or just let the operator choose the temperature. And while solderers are trained, the process still needs to be validated for the temperature range that's being used. If the range is too vast, the end product quality will not be consistent. And there are three methods of wire stripping. We have mechanical, thermal, and chemical. The most popular method is mechanical. Large automated tools or small handheld tools can be used for this. Either way, these tools have wear parts and require regular maintenance. It's important to know how often the tool needs to be checked and to have a nice supply of blades on hand as well as other wear parts. So predictive maintenance is very important. Without it, your operators may have to get creative. And when I was a master instructor, I had students that would pull me aside to show me their little tricks of the trade, like placing a 20-gauge wire into a 22-gauge slot when the blade wears out. That would be a non-conformance. The proper maintenance of tools, process validation, and sticking to it is the only way to ensure consistency. And Paul, you wanted to talk about crimping.
Crimping is one of the key processes that bring wire and cable harness assembly into the special process umbrella. As an OEM, I would think the rigor of a Metacred audit conducted by a subject matter expert would bring significant value to your supplier selection criteria. As mentioned earlier, this is not a quality system audit, but rather a product realization audit focused on the methods used to convert your requirements into hardware that meets your communicated expectations. Thank you.
And we also want to look at safety and reliability. Electrical testing is first. Our auditors make sure all and only the equipment that is called out on the work instruction is used, and also that it's in good condition and does not damage the product during testing. Are the test fixtures properly maintained? Are test failures documented, and we're not just testing until it passes? Is the test protocol being strictly followed? These are things that we look for. Counterfeit components are the number one concern for the defense industry's DCMA, and I'm sure it's very high on the list for the FDA as well. We always hear, well, we don't buy from brokers, so we should be okay. But counterfeit parts find their way into the supply chain in many ways, so you still need to have procedures in place to stop counterfeit material from getting past receiving inspection. Here's an example of fake wire, the picture that you see. The top photo is fake. It's made from aluminum instead of copper, and that makes it a fire hazard. With regards to reliability, is the product an IPC Class 2 or a Class 3 product? Sometimes people don't know. So we'll be looking, is it on the drawing? Does the operator and inspector know the differences between Class 2 and Class 3? If the product is not built and inspected to the correct class, the product will not be capable of performing under certain circumstances. Simply the environment or vibration could cause issues with that product. Also, mechanical testing is covered during the audits. One of the biggest issues we find is failure to perform pool testing correctly. And Paul, I believe you had something to add.
As a material scientist in the wire and harness industry, I had concern for this test from the first day I saw it. The way that we use a V-notch and we pull on an insulated, or excuse me, a crimp with an insulated or insulation crimp on it, which is only supported over about 20 degrees of that entire circle. IPC tells us the insulation crimp has to be removed from the equation to accurately measure this, and to accurately measure it, the load must be applied axially. In other words, if that terminal bends up during your test or down, you have effectively impacted the accuracy of that test. And because it's a destructive test, there's no good R&R method that I'm aware of. So your test equipment has to be calibrated and reliably maintained. I think that it's important. An important part of this entire industry is that test, and there's a lot of controversy as a material scientist surrounding it. Thanks, Julia.
You're welcome. And with regards to material management, I always like to stress, read the technical data sheet. So many times we'll see adhesives or potting materials being mixed, applied, and cured not to the manufacturer's specifications. That's fine if it's been qualified, but when the default is the manufacturer's specification, we wonder, does the operator know what that is? Our auditors often find that oven temperatures are not set correctly, or time in the oven is incorrect, or it's not recorded. If it's not recorded, they have no idea how long the product has baked. We need log in and log out times as part of our device history record. These are the top non-conformances that we found, and the reason why I've chosen some of the earlier examples. One of the things, this is an international program, and translation is important. So English is the official language of the Metacred program, and we have gone to places overseas where maybe they didn't do a really good job in translating their documents and their procedures into English for us to read. Also, as you've already heard, process validation is a big key nonconformance. ESD, electrostatic discharge, that leads to latent failures and failures in the field. Preventative and predictive maintenance. FOD, foreign object debris and damage, FOD can transfer to product, affect solderability. Debris can even cause a short. Counterfeit components. Also, uncertified personnel. Product class not identified. So is it class 2 or is it class 3? Recording rework. Excessive rework can lead to solder joint failure and a fraudulent device history record. A lab can kind of tell by the thickness of the intermetallic bond if a solder joint was heated repeatedly. So we stand back and watch the solderers as they work, and if we see them hit that solder joint the third time without writing it up, that would be a non-conformance. We also find some non-conformances with the purge process, shelf life and work life, and pot life. When a product is mixed, the time should be recorded and the work life should be known, not I just use it until it starts to harden and I can't use it anymore. We see a lot of operators that do not know the work life. And why should they if it's not written on their work process? In addition, hardness testing might also be required. Solder purity and solder bath analysis of the solder pots. They need to comply with the J standard 001. Soldering iron tip temperature. We have a lot of issues with that. We will see operators arbitrarily changing the temperature. Maybe they don't have the right size tip in the iron, and it causes them to change the temperature. Gold removal. This leads to gold embrittlement, and we discussed that in the past, and electrical connection degradation. And also pull testing is one of the top non-conformances. And William, you had something to add to this list.
Yes, I did. Thanks, Julia. In addition to these top non-conformances, the vast majority of defects that I've witnessed are due to termination with the wire strip or crimping, such as wire positioning, or using worn or non-compatible tooling for the termination, or ineffective soldering, as Julia alluded to earlier, including insulation displacement termination. The main contributor is that what I found is that suppliers that are producing these types of products do not have adequate or are not using magnification. Recently, IPC WHMA 620 Revision C updated the magnification requirements to help aid in reinforcing the use of magnification. I find it very interesting when I perform process audits at suppliers that there is little to no magnification used prior to final inspection. And in most cases in final inspection, a lot of the critical components or the terminations that need to be viewed are already covered and assembled in the assembly and cannot be inspected at that point. One other thing that I want to add to with top non-conformances that I've seen consistently in periodic intervals throughout my tenure here is hardware torquing. For whatever reason, it seems in the industry that a lot of suppliers that are connecting screw locks and jack screws and strain relief, back shells, and all that the hardware that goes with that tends to not follow or not seek the manufacturer's recommended torquing requirements. And if they are not listed, to develop a torquing requirement versus just make it hand tight with a screwdriver or something like that. We've seen a lot of strain reliefs on jackets and connector back shells come loose, which then create a problem where they arc to ground or create a shock hazard. So I just wanted to add that to these top non-conformances. Thank you, Julia.
Thank you, William. Here are some typical initial root cause responses that we receive from suppliers, and I think you'll see a little bit of a theme here. We see lack of understanding or lack of clarity, misunderstanding the requirement, unaware of the requirement, or thinking that they have no customer requirement, no requirement for shelf life from the customer. Lack of procedure. Procedure was not well defined or not in depth. Tooling specifications not clearly understood, misinterpretation of the standard. So again, as I was looking at past audits, I noticed a theme. One of the benefits of the MedAccred program is that you learn a lot from the program, from the other subscribers on the task group, from the auditors, from the staff engineers, and the other suppliers. If you attend the meetings, and it's free to attend, anyone can attend the open meetings. You can bring up any questions that you have. A lot of these issues are discussed. What is the medical device industry doing to improve cable and wire harness quality and supply chain oversight? Well, they've developed the MedAccred program, and they formed task groups. And our cable and wire harness task group has some subscribers. The subscribers are Philips, Stryker, Johnson & Johnson, GE Healthcare, and Baxter. The group, again, is open to subject matter experts from OEMs, contract manufacturers, and suppliers. And in the task group, we developed this audit criteria. We also approve subject matter expert auditors that go out and perform the audits for us, and then we grant the supplier accreditations. Metacred accreditation is used by OEMs and contract manufacturers as a criteria to award new business and also to oversee their critical process supply chain quality. And suppliers use Metacred accreditation to ensure final product quality and improved manufacturing operations. If you have any questions, please feel free to contact me. You can see my information there, and also you can contact Justin McCabe, and his information is on the slide. And Courtney, I'll turn it over to you now.
Okay, thanks very much. We'll start the Q&A session. If you have a question, please feel free to submit it using the Q&A panel located at the bottom right of your screen. After typing your questions in the space at the bottom, hit the send button. Please be sure to direct your questions to all panelists in the Ask menu. Your questions will not be seen by other members of the audience. So Julia, I guess, or any of you, first question is, you say that in the initial root cause response, it's often a misunderstanding of their requirement. Do you think in general OEMs aren't including sufficient clarity in their service agreements to inform the contract manufacturers or the cable and wire harness users of what to do, what techniques and what materials are to be used?
I think that's part of it. And I think sometimes, we don't know the right questions to ask. So the contract manufacturers might not come back and clarify, training requirements. Do they need a J standard certification? I just talked to a gentleman today, and he wasn't sure if he needed just the 620 or the J standard. And also, it's a big misunderstanding, I think, with the technical standards. I know in printed circuit board manufacturing, the J standard 033 for moisture-sensitive devices, I like to call it the largest misunderstood standard there is out there. So I know that's the case with other things, even manufacturers' instructions. Paul or William, did you have anything to add to that?
I can add a little bit to that. I used to be a development engineer here with GE, and so when I was in that role, I had designed, I'm going to say, 125 different cable assemblies for power management and signal transfer. In that time, I had never visited a cable and harness manufacturing facility. And so I was just using my book knowledge and the understanding from previous engineers to design my specifications. And being an OEM manufacturer, obviously we subcontract that to our suppliers. So once I came into the role of supplier quality and started visiting suppliers to see their process capabilities and the different technologies, I was made quite aware how insufficient my engineering documentation specifications were that we were sending to our suppliers to manufacture processes. When I was in the engineering role, I assumed that the contract supplier was the expert, that they knew the technology, the most appropriate technology. They understood all the capabilities and the industry standards, and they would apply them appropriately. So I think there can be a little bit of a misunderstanding from the customer OEM side to the contract supplier, expecting that because the contract supplier, that is their core competency, they know everything there should be to know, and if our engineering documentation wasn't complete, they would come back and tell us that. So I think there's a little bit of misunderstanding and maybe not the experience on the OEM side, and that OEM is expecting that through that PO or through that contract that the contract supplier is going to take care of those things. But yes, there is a huge gap there, and now being in supplier quality, I tend to do a lot of translation of our documentation, engineering documentation, with our contract suppliers and vice versa. I mentor a lot of our engineers on what a supplier's capability is and what isn't, as well as what the industry standards say and require.
Oh, that's really interesting. Does Metacred help fill that gap, or is that something separate? So, in other words, if you had, as an OEM, if you had your supplier accredited, getting a Metacred accreditation, that would obviously provide you further assurance that they do know the specifics, but it's still, does it fill a communication gap, I suppose, with the OEM and the supplier?
Paul, I think you could answer that question.
I think I've seen in my tenure in cable and harness a steady improvement in our customers' understanding of what they're asking for, and then the ability to let us help them improve their designs to save them both money and time. So from my desk, I've seen a steady improvement in it, and I think that a lot of that has to do with the fact that our customers have more consistent folks, and they're starting to learn that if they ask us up front, we can help them and save them money in the long run. Save them money, get them a higher quality product. So that's from my desk in the last few years what I've seen.
And let me just add that a lot of the contract manufacturers in the past, they would not talk to their customer OEM unless they absolutely had to. And I see with this Metacred program that you have a lot more communication between the OEMs and the contract manufacturers. I see more of that camaraderie in the task group meetings.
That is helpful. Thank you. You must have just been the most clear explainers, because those are all the questions we have. So thank you so much, because I know this is such a critical topic in the medical device industry, and as you said, it looks like there is kind of a misunderstanding or a knowledge gap. So thank you for helping to fill that. We welcome our listeners to access a recording of today's webinar that will soon be posted on our YouTube channel. The next Critical Manufacturing Processes webinar is on June 21st and will be on plastics, both injection molding and extrusion. And as usual, we'll feature a staff engineer from PRI and at least one representative from industry that's an expert on that topic. Thank you so much for listening. Please watch your email for an invitation. Thank you for joining us. This concludes today's webinar.